almost there. Get a better view if you come around this way. Now I need one volunteer with strong lungs. Look at your lungs. This fella right here. All right, come on up here. Now, I need you to make me some acid. You know how to make acid? This is a experiment that explores the properties of carbon dioxide. This is water. This is a universal indicator. So universal indicator indicates a whole universe full of stuff here. So if I drop a few drops into here, let's see. More maybe? Let's get a bit of color. It's got a bit of color to it. It's green, kind of green, right? Well, that's water is fairly neutral. So this is going to indicate the pH level, whether it's acidic or base. So it starts off, if I put a little sodium hydroxide in it, that's a base. Look at that. It's kind of a blue, kind of a purple. Now, the yellow would indicate an acid. Stand right here for me. Look at that, that's almost the color of your sweatshirt, isn't it? Look at that, maybe your sweatshirt is a base, huh? Okay, get that open. Okay, go ahead and stick that in. Now, blow in, don't suck, just blow. Okay? Make some bubbles. Yeah, you can hold the bottle. There you go. And stand so everybody can see it, that's good. Go ahead and just blow. You can blow gently, you don't want to splash it all over yourself there. Just blow gently. So he's full of carbon dioxide. Most of us are full of carbon dioxide until we exhale. And then we inhale, take the oxygen out of our lungs, put carbon dioxide in, then we're full of carbon dioxide again. So he's blowing carbon dioxide into the water, and that carbon dioxide is dissolving, slowly forming carbonic acid. So keep blowing. Are you getting dizzy yet? Okay. Now, carbonic acid is a fairly common substance. Carbonic acid is what makes your soda fizzy. Now, the acid is the dissolved gas. So you can let the gas come back out of solution and get carbon dioxide back out of the liquid. It comes out of your soda. It'll also come out of your beer or your champagne. Same thing, carbonic acid. Different processes make it, but it's there. Now, if you notice on a champagne glass or a beer glass, or perhaps if you have like 7-Up or a soda that's light in color, it's easy to see that the bubbles don't just appear out of nowhere. The bubbles always appear at some spot on the side of the glass. And that's because the gas needs some place to form. It needs some place to come out of solution. It needs a nucleation site. Some imperfection in the glass. How you doing? Okay, keep on. Some imperfection in the glass upon which it can form and start the bubbles. So next time you got a bottle of something fizzy, look at exactly where those bubbles are forming. It may be a microscopic imperfection, maybe one that you can't see, but I'll guarantee you it's there somewhere. Okay, maybe I should get 2 straws. Keep blowing. Keep going. It's a little fainter than it was before. That's a good sign. Alright. Now, who's seen the Mentos experiment on YouTube or on TV somewhere? Alright, most of us have heard about the Mentos experiment. Now, the reason that the Mentos works is that although the Mentos may feel smooth to you and I, it's microscopically very rough and very bumpy. It's full of little nooks and crannies and little sharp spots. just like a tiny little English muffin, right? It's got a very cratered surface. So there are millions of little nucleation sites for the gas to form on. You dump that in, and poof! All of a sudden you've got millions of bubbles forming all at once, and you get the Mentos fountain. Now how's that feel? Let me take that for a sec. It's blue now. You have changed color. Keep working. You're gonna make it yellow. So make lots of carbon dioxide. Now, a couple of notes on how this particular experiment works. You can come right up to the cones. It's not going to get you. However, you'd probably be better off standing rather than sitting because these little pins, these sliders are supposed to cover the pinholes. Sometimes they don't slide down, and you get a little squirt out one of these pinholes. So I've tried to aim them right there. So that's the only place that you're likely to get wet, right there. But if you're on your feet, at least you can move. How's that going? All right. Yeah, I think we're starting to get an aquamarine there. Maybe I put too much bass in it. It's taking a real long time here. You dizzy yet? No? Wow, well, I would be falling over at this point. That's why we have the volunteers, right? Okay, you keep blowing. Ooh. I think it's green. I think it's green. Let me have a look at that. Yeah, that's kind of green now. That's green. So we're back to neutral. There you go. Now make it yellow. Don't worry, it's not like anybody's watching or anything. I think we're getting close. What's your name? Jackson, he can still speak, so he's not hyperventilated yet.
There we go.
So he's actually created enough acid to neutralize the base I put in there. And I think we're starting to get a little tinge of yellow in there. Yeah? Okay, it's getting yellow slowly. Pale green. Alright, I'm going to call that yellow. Yeah. So thank you very much. It was Jackson. Thanks to Jackson. Let's give him a big round of applause. He's walking down a little bit of a stagger there. Okay. Now. So yellow came out here to actually watch the experiment, so I'm just going to go ahead and pull those pins. And remember, what we've got happening here is carbon dioxide coming out of solution because of all the nucleation sites on these microscopically bumpy candies. Now, usually I'm the only one that gets wet when I do this. Let's see if I can do it without soaking myself. It comes straight back down on me. Wow, that was pretty high. That was our explosion of the hour. Thank you very much for your patience.
Oh yeah, that's
It was fun, huh?
Joshua,